This example comes out of the beginning of Chapter 2, where we start talking about derivatives. 2.1 is called First Principles. To start off with, we'll do a question that we've been asked to do in the previous chapter, in Chapter 1, find the slope of a tangent line. And we'll do this with one of your limit equations. In this case, I'll use the limit as h goes to 0 equation. So slope equals limit as h goes to 0 of f of a plus h minus f of a over h. I like to say, well, if a is 1, if I'm doing it at 1, I can do the limit as h goes to 0 of f of 1 plus h minus f of 1 divided by h. Now, what does that look like? The limit as h goes to 0 of 2 times 1 plus h squared minus 7 times 1 plus h minus f of 1, which is 2 times 1 squared minus 7 times 1. All of that divided by h. Now, lots of things are going to simplify here. Limit as h goes to 0 of 2 times 1 plus 2h plus h squared minus 7h. And then 2 minus 7 is negative 5, so I have minus negative 5, so plus 5. And all that over h. As we expect when we've done these in section 1.4, 1.5 in the last chapter, the constants end up canceling out on the top, and everything ends up with an h in it. And you have 4h plus 2h squared minus 7h divided by h, because the 2 minus 7 plus 5 give you 0. If you now factor out an h top and bottom, you end up with h times and as h goes to 0, I get an answer of negative 3 for the slope of my tangent line. Now, that was plenty of work, and I realize now that I'm going to have to do that for x equals 2, for x equals 3, and then in general for x equals a. Let's skip to question D. So that was the answer to question A. If I do question D next, I'll actually be able to use my answer as to give me very quick answers for A, B, and C if I would have done this in the first place. So slope equals the limit as h goes to 0 of f of a plus h minus f of a over h. Now, leaving this as an a, not putting in a value, I have 2 times a plus h squared minus 7 times a plus h minus 2a squared minus 7a, all that over h. Now, very similar to what we did above, except there's a in place of the 1. Put the limit as h goes to 0. 2 times a squared plus 2ah plus h squared minus 7a minus 7h minus 2a squared plus 7a, all that over h. So without cutting too many corners here, show my work, I've got 2a squared plus 4ah plus 2h squared minus 7a minus 7h minus 2a squared plus 7a. Now, again, everything that doesn't have an h in it is about to go away. The 2a squared minus 2a squared goes away. Minus 7a plus 7a goes away. And I end up with 2h squared plus 4ah minus 7h over h. Divide everything by an h, and I have the limit as h goes to 0 of 2h plus 4a minus 7, which, if h goes to 0, is just 4a minus 7. That might not seem like a particularly important answer, but if I realize that in question B, if I let the a be 2 here, I would just have 8 minus 7, which is a slope of 1. And for question C, if I let the a be 3, I have 12 minus 7, which is 5. And if I went back and checked question A and said put in a equals 1, I'd have 4 minus 7, which is negative 3. And so we're getting close to the idea of a derivative. This expression I've come up with at the bottom here of 4a minus 7 allows me to find the slope of the tangent line to this curve at any value a, at any value, and realistically, as we go further into the next example, we'll call this a derivative, and we'll use an x instead of an a, and say if you put in any number x, whatever value you want to get your tangent line at, this is called the derivative of that function, and I'll go over that more in the next example.